Welcome to the project demonstration of heartbeat monitoring and voice-based alerting system by using PIC microcontroller. So here we are going to calculate the heartbeat of the person, those who place his finger on his pulse sensor. So the pulse sensor will calculate the reflection rays from this LED and from your body finger skin, and that will be converted into the analog signal. The analog signal will be given to the A0 pin of our PIC16F72 microcontroller. So we have coded the microcontroller to calculate the timing between the two pulses. So there we'll get the, for example, X seconds for one pulse. Then we are going to convert that into 60 seconds of pulses. So means how many seconds will be taken for the pulses in a 60 seconds. So then we are going to get the pulses, like consider X second per pulse means, so in 60 seconds, how many pulses we are going to get that. So this is a calculation done by the microcontroller, and that will be converted nothing but BPM, beats per minute. So that will be displayed on the LCD screen. So we have to set the limit for the abnormal heart rates. So if it is below 60 BPM, then low heart rate message will be announced from this API3383 voice module, which is interfaced at pin number C0 to C3 pins. And we have interfaced this LCD pin number B2 to B7. So coming to this API3383 module, so API nothing but audio playback recorder. So predefinedly we need to store and record the voices from this microphone, and that will be stored inside this IC. Whenever we want to play the respective voices, so we need to provide the trigger input pulses from the microcontroller. So as we discussed, that is C0 to C3 pin. And next, the whole system getting power supply from this adapter. So it has the inbuilt transformer and rectifier and filter and regulator. So it will take 230 volts AC input and provide as a 5 volts constant DC output, which is the main operating voltage to the whole system. So on this motherboard, we have the three major components. One is the microcontroller, PIC16F72, and the next, this one is a steel plated one, is a crystal oscillator, which will provide the 20 mega clock frequency to the microcontroller. So the main purpose of this clock frequency is, so we have coded the microcontroller with set of instructions. Each instruction will take one pulse. So like that, we are providing 20 mega clock pulses per second. So controller can execute 20 mega instructions per second. And the next is restart purpose. Press and release reset switch, so that the controller will start from starting onwards if is there any abnormality detects on the motherboard. So let us see the demonstration. Before on the kit, we should place the finger on the sensor, pulse sensor, and on the power supply. So initially welcome message. So welcome message announced and welcome message displayed on the LCD screen, and thereafter continuously monitoring. So for abnormality, just shake the finger just to make the abnormality. So when it crosses 100 heart rates, so then high heart rates. Coming to the low. So just by shaking the finger on this heartbeat sensor, we can make the abnormal heart rates. So it's normal now. Right.